When we think of a light and shadow, we usually depict image of a ball with light source on it. This easily explains how light and shadow work within simple environment without any extra props in it. So using complex light is difficult thing if you don't really learn the physics of light and other important parts of it. That's why understanding the basic physics will actually help implement lighting in the drawings, and you'll also have easier time to make more complex compositions. And that's why today I want to make video about light and shadow with the very basics, because why not? The universe is built in hierarchy. From afar we see galaxies. Galaxies are made of star systems. Within those star systems are planets. On planets there are mountains, oceans and living beings. Life itself can be broken down further and further. Organisms are made of cells, cells of molecules, molecules of atoms, and atoms of even smaller building blocks, elementary particles. From these particles, everything we call matter is constructed, the very body of existence. But it's important to remember, not everything in the universe is matter. There is also light, and it too has its own fundamental particles called photons. Light is the fastest thing in the universe. In fact, everything in the cosmos is governed by balance, by limits. And one of the most fundamental limits is speed. We call it the speed of light because it's the maximum possible speed for transferring energy and information. In reality, photons form not only the familiar visible light, but also radio waves, microwave, ultraviolet, X-rays and even gamma rays. All of this belongs to a single system called the electromagnetic spectrum. We won't go into detail about every range because what matters to us is just a small slice. The visible spectrum is the only part of electromagnetic waves that the human eye can directly perceive. Everything else remains invisible to us, though it can still be detected by instruments. You might be wondering, why do we see only this narrow range of the spectrum? The answer lies in evolution. It's the range that turned out to be the most efficient and useful. Put simply, the photons in this band carry just enough energy to trigger chemical reaction molecules. But it's not just about what was convenient for evolution. Earth's atmosphere hardly absorbs waves in this specific transparency window. The radio band and the visible band are the main two corridors of the spectrum that can pass freely through the atmosphere. That's why they became the ones available both for evolution of vision and for astronomical observation. Well, if Earth didn't block most of those waves, we probably wouldn't even be alive today. So yeah, thank Earth for that. And don't forget, do not pollute. Did you know that everything you see is actually fake? We never see an object directly, our eyes only capture the photons that are reflected or emitted by it. In other words, we don't see the object itself, we see the light. If surface looks red, that means it absorbs almost all other wavelengths of light except the red range, and that's what the eye detects. A white sheet reflects nearly the entire visible spectrum, while a black surface absorbs almost all of it. Our brains fills in what we call reality. Vision isn't like a camera, it just makes snapshots. Much more complex system. That's why it's so easy to trick our vision and brain. We perceive optical illusions, flashing colors, even lines that don't exist because the brain would rather fill in what it thinks should be there than leave an empty gap. Why is the sky blue? As sunlight travels through the atmosphere, it collides with air molecules. Shorter wavelengths like blue scatter more strongly than longer ones like red. That's why during the day we see the sky as blue dome. Why is the sunset red? When the sun is low on the horizon, its light has to pass through a much thick layer of atmosphere. The shorter wavelengths, blue and green, get scattered away, while the longer ones, red and orange, make it through and reach our eyes. Now let's move on to actual drawing part and learning how it will actually look in real life instead of just doing theories. And let's start with a simple picture of this sphere and how light source will affect to it in this environment. So there is main zones of light. It's a direct light is somewhere casting like from somewhere there, shadow that this sphere is casting. So if you studied values before, it'll be super easy to understand. So there is also a half shadow. This is an area that receives some light but not fully because it's partly blocked. So somewhere there, this part of it, why is it not dark as this part? Well, it's simply because of the reflected light. So light is here as well, so it bounces to this ball, this part more bright as you can see. And lastly, it's a shadow, the region where no direct photons from the source arrive, only reflected light remains. As you can see, shadows are never completely black, unless the object is isolated in total darkness. Well, it's simply because like light reflects from this wall to this shadow, so it's a bit monotone color, like background of it. The light that reflects from the ground to the ball and the yellow light from this ball reflects to the ground, so that's why the shadow has a bit of a yellow tint in here. And it's really easy to learn, isn't it? There is also one thing to remember, and it's super easy, probably you know it by yourself, and it's shadow's sharpness. When the object is close to the shadow will remain the shape of the object that it takes. It'll be super sharp. If object is far away from the shadow becomes a bit more blurry. So it's better to consider this while drawing. So we've covered the basics already, but there's many more aspects of light that can bring drawings to life, and it'll be super nice if you consider drawing them as well. It is basically warm and cool light, so evening sunlight, like in this case, creates warm tones. So artists often use warm light with cool shadows or reverse to add more vibrancy. So you can easily notice, like in this picture, and the light parts are warm and shadowed parts are cool tone. There's also that some materials let light pass beneath their surface, like skin in this case, or marble or wax. So basically, light travels inside this object and bouncing around many times before exit. So this creates a soft glow from within, for example. Fingers, like in this case. So in drawing, these effects help make materials look a bit more realistic, but don't make it look too realistic. You have to have balance, you know. Also, there is a specular highlight. So on smooth surface like metal, glass or water, highlights are sharp and bright. So on matte surface, they're soft and diffused. Also, there is refraction. It usually happens when light bends as it passes through transparent materials like water or glass, or water glass, like in this case. So this can distort objects seen underwater or through a lens. This also happens when you look at the lake in this case, right? This part is very reflective, and you can see how the mountains or the forest is reflected, but the closer object is to you, the less reflective it becomes, and you can see the objects underwater. So light reflects this way to your eyes. From here, it's just practice applying directly in your drawings. Now you can experiment more confidently with different compositions and lighting setups in your art. I hope you enjoyed this video in this format. It was really fun working on it.